wrangle your way into hurting yourself. Lots of stretching. That's got it. Okay. There's kind of two reasons to be in there. Troubleshoot and repair. Something isn't doing what you want it to do. Second reason is to upgrade something. Right? You get in there and the owner wants something new. Either a new additional component or a replacement of a component. There are some occasional instances where a component can be upgraded very easily. The original installation, connectors, tray, everything, all still work. So you just pull the old one out, put the new one in, everybody's happy. Other occasional options may be to pull a component out, send it back to the mothership, and they upgrade it. Like you want your Garmin, whatever it is, upgraded to WASP, or maybe you can upgrade a transponder to ADS-B with minimal. You might have to have a couple of wires, but not a whole lot of extra work. Okay. It's always, there is no easy way to do this. Well, I suppose it depends on the airplane. The bigger the airplane, probably the easier it is in terms of access, getting access. In general, however, the bigger the airplane is, the longer the runs are, so the harder it may be to, particularly if you have a mid-harness problem and you're trying to troubleshoot out where the problem is. I actually spent yesterday playing around on the USS Midway. Oh my God. You want to talk about a wiring nightmare. Every nook and cranny overhead has wires and pipes and plumbing and stuff running through it. All either conduited and under multiple, many layers of paint. I can't imagine what it's like working on that thing. And having wire runs that literally go miles. So this is one of those ones where you're going to have to spend a little bit of time studying. Not a little bit of time, probably a lot of bit of time. Doing some studying schematics, going through all the troubleshooting trees, everything else they have, getting a little bit of a big picture, and then going in and diving into some of the really detailed nuance. Start here, go to there, measure this, go to there, measure this, and you kind of got to do it. I will say more and more as we sort of move into the future. Two things are happening. One is all the troubleshooting charts are getting better and better and more reflective of what you need to do to isolate the problem. The other thing that's happening as we move into the future is particularly more sophisticated systems are getting pretty good at self-diagnosing. Okay, and many of the computer systems, they might tell you what's wrong, but they'll tell you that's an error. And they might even give you a code or some other bit of information that you can then either pass on or look up, so and get some sense of what direction to go. It's a good idea if you're going to do any of this kind of work at all, is get yourself a digital camera. Now, most of you, if you have a telephone, you have a digital camera. Mm. One of the things I found on the Midway, which was really cool, was one of those old phones you pick up and you go. And some of you don't know what that is. So, lots of digital pictures. It does two things for you. One is it helps you remember where everything was, because it may be a while before you get back to there. The other thing is it does help you to figure out when something's was done wrong, particularly in routing, where stuff is located, how it's attached, how it's connected. Okay. So the most common form factor for avionics bays in smaller airplanes is they make pull-out, easily accessible pull-out trays. Easily accessible. It's easy to get the main component out. The tray itself may not be that easy to get out. As you can see, that one's been pretty abused. But they'll often have, this is sort of a multi-part tray, where this part is what faces out, and then there's a whole back assembly that can be unscrewed and disconnected, and then the back assembly, the connectors in it can also be unscrewed and pulled out of there. So this is a pretty convenient way of doing things. Then oftentimes what you might find yourself doing is building this up into a stack of trays that all come out as a single unit. Okay, and then when you go to upgrade, you're going to be disassembling this thing completely and putting back together a new stack of trays. Okay, typically they aim for a form factor of 6¼ inch wide, and then the height is just a function of whatever the device is. Okay, if it has a nice panel display, it's going to be a little bit taller. They do make a fair number of units that fit in standard, or avionic units that fit in standard 2¼ or 3 1/8 inch holes. Autopilots, all kinds of electronic instrumentation, etc. So, and they typically use 4 fairly short screws to hold those in. Again, each of these you're going to want some decent service loops on them. It's fairly common for these guys to be about 12 inches or less deep. So it's not uncommon to have an instrument panel and then a bulkhead somewhere back there that's structural. Longer components are components that are at 12 inches, but then also have a pigtail sticking out and need some distance behind them to keep minimum bend radii held. You're going to have to measure all of that before you start doing a significant upgrade. The other thing is, once you put the stack together, it actually has to fit in there and not sit up real high so suddenly you can't see out the nose of the airplane. One of the big changes that we're seeing in avionics that's actually coming down to us, the world of airlines, is they take all of this magic box stuff and they just put it in a little box somewhere. You can put that anywhere. And all the wires go in and out of it, plus a smaller set of wires that then come over to the display control head. Okay, and the display control head oftentimes doesn't need a whole lot of wires to it. It has its own little small computer in there, and they send data back and forth between the controls and the display, whatever is displaying. So it's it makes it very, very easy to take this small, or whatever this radio is, or transponder, or whatever you want, put it wherever you need to make it easily accessible, or close to the antenna, or close to a power source, and then run the control the display wires up to the instrument panel, which have a fairly small, not very deep display or control panel, buttons and knobs. The other thing that's become a sign of the times in the last 10 years is super multifunction switches. Okay, double stack switches where you have an inner rotor, an outer rotor, plus the whole thing can click in one of 4 directions, plus it can pop in and out, and the outer roller can pop in and out. They often call them encoders. And in fact, the strategy is such anymore that in the world of the avionics device, the encoder is just something that's going tick, 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 tick as you rotate it. It's not something that's going 1, 2, 3, 4, 5, 6, 7, 8, 9 to different wires. It's just going tick, tick, tick. And wherever it's at, the computer inside is saying, okay, they rotated the encoder 72 notches or 22 times or however many times they moved it. They'll often also program behind these control panels where a single button push does one thing, hold the button down for a little while, and then it does something else. Okay. A third thing that can be important with a lot of your contact switches is when does the switch actually do something? When you push down and activate the contact, or when you release? Both of those are 2 distinct different functions. Okay, so the programming behind it may allow for a whole bunch of different options, all of which allows us to, I don't want to say simplify, but reduce display or control function buttons and knobs, etc., down to few, reserve more real estate for display or whatever else is going on, or make the whole thing a lot smaller if you don't need all the display space. The other advantage by remote controlling stuff is if you put all this avionics right up here in the top where all the sun's beating down on it, and if it's got an engine up front, the engine's heat is coming back, so this is going to be a pretty hot proposition, as opposed to being able to move some of those components elsewhere and then feed some cooling air to them. You might provide much better cooling for those devices. The other thing you can do is do a fair amount of sharing. So for example, in my bigger airplane, I've got 2 display units and I can flip-flop data. So I can put in it, if the co-pilot wants to fly, I can take the electronic flight information data, kick it over to the engine management display, and take the engine management display and bring it back over to the pilot side. Okay, so significant advantage of options that you can do. And one of those display units, the electronic flight information system in my airplane is now certified, approved for use in a variety of different certified airplanes, Cessna 172s, etc. So first thing you're going to have to consider when you do any of this work is deal with the structural considerations. Okay, how much does this stack of radios weigh with all the wires attached to it? My little plane, because I went with an integrated electronic system, all of this and the gauges ended up weighing, if I did it non-integrated, just hardwiring a bunch of radios and stuff in there, it would have weighed about 65 pounds. Because I went with an integrated system, it actually weighs about 12 pounds. A whole lot lighter. I saved a lot of weight. I also significantly reduced the amount of current used. Well, let's take that number. What does 65 pounds weigh at 6 Gs? Huh? Well, let's see. 65 times 6, 30, 360 plus 30, 390 pounds. Okay, that's kind of heavy. And 6 G is what the plane's rated for. That means I have to actually structurally be able to handle up to 10 Gs. I get the strength of that particular plane handles up to 10 Gs with no permanent deformation. I'm allowed to fly aerobatics up to 6 Gs. So 10 times that's 650 pounds. That's a pretty significant weight just in this thing, right? Well, structurally, it's got to be able to handle that. Now, do you guys feel like you're enough of an engineer to be able to do all that work? Yeah. You're going to have some route for all these wires to come in and out, as well as some means for the components themselves to come in and out. And I assure you, flat out 100% assure you, the manufacturer wasn't thinking about being kind to you when they designed all this stuff. That entire upper structure or any part of the airplane, in terms of making it easy on your life to get stuff in, bolt stuff in and out of there. So again, good service loops. You probably are going to need to put some spacing between components. Now, oftentimes, it's sort of funny, this tray doesn't have any here, but notice the little divots that stick out here. A lot of times they'll also put some divots along here to just impose a little bit of space between components. Okay? Now, if I put a cooling fan on there, that's going to give some room for cooling air to blow through there. So you may want to put just a small amount of spacing for cooling. Also, something to keep all the power wires, all the audio wires, and all the coaxial antenna wires separated from each other. Okay, with some physical distance. Otherwise, they will talk to each other in ways that you won't be happy with. So yeah, the other issue, not only can physical loads of pulling back on the stick or pushing forward on the stick, but vibration can start damaging these things, right? So much vibration is going on. Is the instrument panel rubber mounted? Many of them are rubber mounted. Okay, now I just added 650 pounds to a rubber mounted instrument panel. Can those rubber mounts handle that? Same thing true if I take an antenna and bolt it on the outside of the airplane. Okay, and well, that's a Piper Cub. It goes 80 miles an hour. It's probably not too much to worry about. On the other hand, it's serious or something else, and it's a pretty thin area of skin that you're mounting the antenna to, and you're bebopping along at 200 knots. Well, now you've got some things to consider. You're going to have to probably strengthen the skin. You might have to get a ground plane put in there, okay, which means you're going to have to get back in there and lay out some copper, not copper, but sheet metal or foil or something like that. It might be copper. Anything that's a sensing component, AHRS units, compass units, electronic compasses, those types of system, very often they'll say nothing within 12 inches or within 18 inches. When I say nothing, no wires of any kind, carrying any kind of current, no static wicks, no metal containing iron. They just want everything away. Well, guess what? On a small airplane, it can be pretty hard to find a place that's true. And if it's a combined unit, might be it's a compass thing with an attitude and heading system in there. They may also say that given the shape of the airplane, given the shape of the airplane like this, they might say, airplane like this, it's got to stay within some circle of the center of the airplane. So now you got to stay in here. It's hard to find a place in there that's not near anything. You have to somehow or another figure all of that out before you start cutting and drilling. Because my recommendation on all of these is get a plan, lay it all out, get all the paperwork ready, and then figure out what the FAA is going to make you go through as you alter this. Because you do not want to do it all and then find out the FAA is going to go, nope, we don't like that. Okay. So some of these newer systems that are actually sensing, like an electronic flight information system, they're looking to be oriented along the direction of travel of the airplane. So whatever the water line or the ley line, the lateral or horizontal lines of the airplane, but the instrument panel often isn't there. So you're not at right angles. You might be 7 degrees or 12 degrees or some value up. This is also true for some of your gyroscopic instrumentation. Okay? Now, which gyro is that going to mess with the most?
The horizon.
Huh?
The horizon.
Not so much. You just move the little window, you move the little airplane up or down.
And then directional.
Not so much.
All right. One left.
Well, yeah, you're turning bank, right? You're turning bank. What did they do with the turn and bank? Didn't they take that gyro and tilt it? How much did they tilt it? 35, yeah. Some of you guys went to general. Okay. Why did they pick 35 degrees? Well, now I guess I'll take that back. None of you went to general. Where's Larry? Where's David? Oh my. Can the plane fly at 35 degrees from its from its lateral axis? Excuse me, longitudinal axis? Can the plane go like this? There's no physical way, no amount of power is going to cause it to do that. At that relative angle of attack, it would stall. So you physically can't make the plane do that. And for that reason, the turn coordinator will always react to changes to yaw and or roll changes. You can't fly, if we're at 35 degrees, we can't fly that heading. If I'm flying exactly that direction, and then I start to roll, it wouldn't react, would it? So they bring it up enough to where it will always react. Well, guess what? If I tilt the instrument panel, now what? Haven't I tilted that back down some? Okay, all that has to be accounted for. Okay. So some things that need to occur, there actually should be 3 things stated there. If I'm going to change avionics, and this is why the FAA is almost always going to say it's a major alteration. Almost always. I'm going to change the weight and CG of the aircraft, potentially. And it may well be in ways you didn't expect. You're going to pull out 50 pounds and put 30 pounds back in, and some of your CG is going aft instead of forward. Right? I'm going to change the electrical loads of the airplane. Oftentimes, if it's newer avionics, I'm going to be reducing the electrical loads. So that's a good thing, but you still have to document that. The airplane is altered. Therefore, the documentation must reflect that it was altered and altered in a proper way. The third thing, which often gets forgot about, is the instructions for the continued airworthiness of the airplane are probably altered as well. Okay? So now, with my pilot's operating handbook, it needs to reflect the new equipment. The equipment manuals have to be reflected, etc., so that the pilot getting in the airplane now knows what manuals to go to learn how to use the new wide-angle feather bearing that's installed in there. Okay, so all of that has to be reflected in the documentation supporting this alteration. Because of that, the FAA is going to want a permanent record of it. And that's where the 337 comes in. That's why they wanted it to be a major alteration. Almost universal. Now, I think there's a lot of small, minor electrical alterations. My personal opinion is throwing in something like a JPI 450 fuel scan is not a major alteration. Most FAA guys I think you talk to would say, yeah, no, we want a major alteration. Which, yeah, it's overkill. But is what it is, right? You want to go talk to them and make sure that they're not going to be unhappy with you when you go down that rabbit hole. The other side of that is the fact that you go talk to them beforehand shows that you're sort of trying to come from the right place, right? You're not somebody trying to do an end run on. even if they like, nah, don't bother us with that kind of stuff. Doesn't matter. You've still done the politically smart thing, right?
So if you go in and talk to somebody, do you want to get a record that you've actually spoken with somebody so
Well,
that?
you can just make a note.
Okay.
Yeah, make a note. Here's the deal, and this is sort of a funny one, but you are authorized to make a logbook entry. And that logbook entry says the work was done in accordance with dump, right? Well, you're just as authorized to write down a little note. Yeah, I went to talk to so-and-so. Okay, just keep it for your own records. That's evidentiary. Absolutely. What's the guy over there in Washington? Mueller. Okay, Mueller would subpoena you for that puppy, right? Absolutely. Any record you make like that. And for your own defense, that's going to show any other investigator as well as any jury, anyone else, that you're trying to be conscientious. You're making records, documenting stuff, etc. And you're right. There's a lot of inconsistency with every government agency. It's just across the board. Okay. The upside of all of this new technology and all these upgrades we do is things are going to get lighter, things are going to get become lower power consumers. That's good. That's all good. Things are also going to get more complicated, more sophisticated, and the learning curve for the operator is going to be a little bit higher. All right? I think Garmin was actually one of the smartest ones out there. When they first produced the 430, they made a computer simulator. Everything the unit could do, you could do on screen, on a computer, tune it into all kinds of different frequencies, do all kinds of stuff, fly approaches, do all kinds of fancy stuff, and they gave it away for free. Anybody can download it and play with it. I mean, not only did it teach you how to do it, but what a cool marketing tool. Man, you start playing with that, man, this thing's really cool. I gotta have one of these $12,000 puppies. This is cool. Okay, so yeah, it really, this is one of those areas where if you're really doing a major upgrade, that's where you're going to want to talk to the FAA. Now, if it's something you've already got sort of arranged, you've been doing this, you've been putting in this particular stack in the Bonanza A36s for a while as a radio shop, you may already have this sort of hammered out with the FAA. And as long as you're doing the same thing over and over again, they're going to be okay with it. But the first couple of times, they may want to see, okay, let's see some structural engineering work. Get a DER, designated engineering representative, to go through and prove that, in fact, all the math supports what you're doing. I can tell you that building up wiring harnesses takes a long time. I've probably done, I don't know, maybe 3, 4 Garmin 430 installs, and it's 3 or 4 days of wiring, and around depending on what you've got, for which a fair amount of it is just going in there and figuring out what's already there that you have to hook up to, and then what new you have to deal with, and integrating it. But it takes a while. There are a number of companies now that will produce these harnesses for you. Steinair is one. What's the guy back in Georgia? I don't remember his name, but again, there are several entities out there and they make beautiful harnesses. Really nice work.
Don't they have plug and play now too, where they have like a panel that everything just plugs into?
There are some of those options. So, for example, the integrated unit like I've got, the Dynon, it has a whole bunch of different interconnects. So you can daisy chain one to the next, to the next, to the next. And if you need to split out, you can buy a splitter, so 1 into 5. And it doesn't matter. Everything is on a serial bus. So as long as they're all interconnected in the same way, they all talk to each other by multiplex addressing. So in that configuration, yes, you can buy pre-made, already ready-made, or you can buy one end made and the other end not done up, so that you can feed it through a bunch of holes and then finish putting it, terminating it, right? So truly, if you're really gonna do a major update, you really need to sit down and do a whole bunch of planning. This all takes time. Now, how you're gonna bill for that, between you and the customer, you kinda gotta work it out, but it takes a fair amount of time to put it all together. It takes a fair amount of time to sort it out with the Fed. All of this is time for which you should get paid. To some degree, if this is something you're gonna be doing again and again and again, then, you know, it may be worth investing a little bit of your time into it, but, they also now have a number of software options where you design the panel, hit poof, and it produces we see this in the experimental world a lot. It produces a CNC file of some type, AutoCAD file of some type, and you can mail that off to any machine shop, and they'll print the instrument panel. All the holes, drills cut, all weird shapes done, and they'll do it for you. But again, for a fee. The other thing is your planning, in as much as possible, should allow room for other upgrades. As well, it should remove old weight that isn't being used anymore. Now, you go to pull a wire out of a loom, what happens to all the wire lacing that's in that loom?
Loose.
If you can sneak the wire out, it just got looser, right? So should you redo all the lacing? I don't know, if it was a really small wire, maybe not. But for the most part, if you're gonna do any serious upgrade like this, you're gonna be relacing everything. Get the old wire out of there. And then you gotta spend, I know several of you spent some time under panel. The thing that annoys me the most is 50 pounds of old wire that doesn't connect to anything. May or may not connect to anything. Because people got lazy. So again, I always never say always. Right? Actually, you should always never say never either. No absolutes, but it's going to be the truth of the matter is the FAA really has no way to check on you until after the fact, do they? Let's go in and put a whole bunch of new radios in an airplane. Signing off logbook entry. Yeah, it's grand, ain't it great? Go fly it around. How's the FAA ever going to know? Not until an accident or a bizarre, a very rare, unusual ramp check. Are they ever going to know that plane was altered? Unless they happen to be getting in there. Somebody is doing an annual, happens to say something about it to them. The likelihood of them knowing, it's a hit or miss. May or may not happen. That's not a smart thing to do, but they just don't spend a lot of time walking around looking at every airplane and checking the records. That said, they're probably going to say, and this is particularly true if you have an inexperienced crew at the FSDO. Why? They're government pukes. It's much easier for them to say no. Yep, no, we're not going to do anything unless you do all this other stuff. Right? Now, the more seasoned ones that have some rapport with you, they're going to be more inclined to work with you and get stuff done. It's also true that the component manufacturers themselves, they want to sell this stuff. They want it to work in your airplane, so they're going to be able to help you with some reasonable data supporting, hopefully supporting the installation, as well as STCs. Now remember, an STC just gives you criteria by which you can use it to install it in the airplane. It does not approve it for installation in any specific airplane. Okay? That's the individual alteration is the one that does that. So each 337 form can rely on the STC. But it's the 337 form that says that STC appropriately applies to that installation in that airplane. Now, I think the FAA has gotten a lot better. I've done a couple of annuals where, no record, it was clear that in fact the owner still had original 337s, and there was nobody in the FAA could find them in Oak City, could find those records of the alterations in Oak City. So where it ended up when it got submitted to them, or if it got submitted to them, who knows? But when you're going through and checking that stuff, particularly if you're doing 100-hour and annual, it's might be in your interest to make sure that in fact all the paperwork was correctly done. So TSOs exist, the technical standard order. The FAA up until this point for anything electronic has kind of said, yeah, it's got to have a TSO, right? Any upholstery, carpet, anything that can burn inside the airplane, got to have a TSO. The seat belts, the strength and flammability of the seat belts, got to have a TSO. Okay. How about AN hardware? Well, AN hardware, as long as it's built, it's correctly built to some specification, doesn't really need a TSO because it's built to that specification, that AN specification or MS specification. However, you might need a certificate of authenticity on it, an AU-130 tag, with it to ensure that it is in fact approved, appropriate, not Home Depot hardware that made it into our industry. So TSOs really are a set of standards where things have gotten a little bit more complex. So TSOs for radios, transponders, instrumentation, as well as some materials like cockpit interior, cabin interior materials, fire suppression materials, etc. The FAA has been pretty rigorous around it. Well, last year they sort of came around and said, look, we're going to let you guys install a non-TSO component, Dynon D10A, into Cessna 172. They actually formed a work group. Because now I think TrueTrack autopilots, there's 5 or 6 things now approved for use in certified airplanes that are not TSO. The FAA finally said, look, you can't buy this instrumentation, the original attitude and gyros and stuff anymore. You can't buy it anymore. This particular component we're talking about has demonstrated a very high degree of reliability through a whole bunch of different processes, not necessarily TSO'd, but it does allow the plane to keep flying, and it actually improves the situational awareness of the pilot. So let's back off. So they formed a work group. AOPA, EAA, several other national organizations got together, and actually there was a private company that was invented around just the certification process, non-TSO certification, and they've managed to make this stuff work. Well, how do you think Dynon feels about that? Whew, their market just got a lot bigger, didn't it? Okay. Same thing with these other companies. So they're going to get behind it and support it. What's it mean for us? The installers. A whole lot more work. Yeah, a whole lot more options. You bet. This is all to our benefit. But it kind of also means we have to figure out how to make it all work. There's somebody getting frustrated with their electronics. Bad radio. I don't know what that is. It looks like a speaker right there, right?
Yeah.
Yeah, it must have been politics. Somebody was broadcasting politics. I think so. Okay. All right, so let's start talking a little bit about diagnostics, and then I'm going to make sure we get through this in enough time so that we can after break we'll finish this up, and then we'll review for the final. So parts of this I may zip through fairly quickly. Okay. First rule of diagnosing anything is you must operate with some kind of a plan of attack. Spitballing it, throwing parts at it till the symptoms go away is not the way to go. It just absolutely isn't the way to go. So you got to have some kind of a plan of attack. So talk about that. We'll talk about a little bit on testing techniques and some of the analysis you can do. Verification is really, really critical, both pre and post verification and re-verification. Then the other thing and this is where it kind of helps you a little bit to have some expertise with your make and model. A lot of times engineers design stuff badly, right? There's weaknesses. The plug always breaks right there. Okay, this connector has a tendency to do that. Well, after working with that particular product, that Piper Cherokees or whatever, you get to know some of those patterns. Probably not going to talk too much about soldering and crimping because I cover it so heavily in the other class. We'll see how far we get. Okay. The first rule of diagnosis and any kind of a plan is you're going to have to make some assumptions. And there's nothing wrong with making those assumptions, but just be aware that it is an assumption. Okay? And be sort of ready to back up to that assumption and say, wait a minute, that's an assumption, and now I'm getting some clues that maybe that assumption there is in fact a bad assumption. Many times an assumption, particularly if there's a pattern failure, something you've seen before, an assumption can save you a lot of time and the customer a lot of money. Okay, so there's nothing wrong with it. You just have to be really aware that you made an assumption. Most of the times what we're dealing with is assumptions. There are some basic facts. We have some facts. We know that if you do some things to, a lot of what we've been talking about. Okay, if you do some things to some metal and put it in a thing with some electrolyte, it'll produce current. We call that a battery. We know that if you take a bunch of metal and string it all together, we can call that a wire. And that electrons will travel through it, and there'll be a specific voltage drop. And so there are a lot of facts in here as well. But the fairly common assumption is you pull out a schematic and you hold it up and you say, look, I got the schematic and it's accurate. Okay, if it isn't making sense, that doesn't necessarily mean that the schematic isn't accurate. Could be you're confused. In fact, more often it is that you're confused. But I have had schematics be very inaccurate. Okay. Good old Samuel Clemens. He was like the king of curmudgeons. So they're going to save us a fair amount of time. They do allow us to sort of assess and mitigate some risk. So what really makes the difference between a fact and assumption?
There's as an assumption.
A fact is kind of hard. It's an assumption that you've made, an hypothesis that you've done a fair amount of work to disprove and haven't really been able to successfully disprove it. Okay, that's the scientific process, right? Throw out a hypothesis, a statement, this is what I think it is, and then actively go about trying to disprove it. And if you can't disprove it, then in all likelihood, it's probably a fact. Okay? A lot of people get that one wrong. A lot of times, people see the scientific process, and throw out a hypothesis and then try to prove it. That's not the scientific process. That's what a fanatic does. Okay? No, your mind is only open if you're about the business of trying to disprove it. So we're going to assume that Ohm was right, and Ampere was right, Watt was right, and we're going to call those facts. Most facts do contain some assumed elements. So this is something that's kind of hard for you guys. And even as we've already been doing a few of the diagnostic troubleshooting out here, you guys really struggle with this. Okay, you got the schematic, you start doing stuff, testing like that, and not a single one of you have made any notes. Okay, it's to your best interest to make notes. When you measure something, make a note of it. You measured voltage here, you measured resistance there, at wire ump junction XYZ, make notes. Come up with a way of tracking the information that you get. Now, oftentimes diagnostics are pretty simple based upon prior experience. Diagnosing and troubleshooting a charging system, I don't need to make a lot of notes. I've done it hundreds and hundreds and hundreds of times. I'm going to check about 3 things and I'm there. So I don't need to make a whole lot of notes to be able to establish, is it the power, is it the battery, is it the generator, is it the voltage regulator, is it the rectifier? I'm going to be able to figure that out pretty quickly. You guys fairly early on, no, make some notes. Okay, get used to making some notes. Collect data. At the very least, that data is your evidence that you spent this amount of time trying to figure out what the problem was. On the other end of the case, the other end of the extreme, somebody comes along and says, hey, I got this, a troubleshooting problem, and you go through, make a bunch of notes, do all this troubleshooting, ascertain this was the problem, logical conclusion, do the repair, put it all back together, sign the, get the check, put it in the bank, pilot takes off, and 4 or 5 flights later, they get in the airplane all drunk, fly into a mountain, and the widow comes back and sues you. You didn't repair the airplane correctly. Like, well, no, actually, I've got some pretty good records that shows I, in fact, did due diligence. And, in fact, anything I did had nothing to do with the fact the pilot was drunk and flew into a mountain. And now, I've seen that. I do know of an instance where some kids did steal an airplane. They made it off the airport into the wires west of Montgomery Field. I don't know how they lived. I got nothing. And it was foggy. They didn't know how to fly the airplane. They were completely loaded out of their minds. Hit the wires, the big wires. Okay, and sparking, flame, everything. Fall down. They lived. And the FAA, being diligent as they are, actually found some problems with the airplane and went back and talked to whoever the last people were that worked on it. Even though absolutely there's no way you could say there's a causal relationship between the sets of events, right? Now, of course, what the insurance company is doing. They're looking for a way to get out from having to pay. Tough one, though. Does it really matter if everything is airworthy when the people flying it weren't airworthy? I don't know. That's a set of law I would not want to get involved in. So, always have a good plan. Always document stuff when and where you can. Now, this is the evil, evil word. Voltage drop is your friend. This guy is not your friend. Absolutely not your friend. There's something about intermittents that know how to recognize when somebody who knows Ohm's law is nearby and they happen to have a handy dandy voltmeter in their pocket or in their holster. The intermittent is just magical at being able to go away anytime you get near it. You sort of have to have some empathy for the customer, for everybody involved. It can be very frustrating. Sometimes a voltage drop check, an ohm meter will probably isn't going to find it, but a voltage drop check will show a little bit of a drop that's associated with the intermittent. What's the burnt 182 down at Montgomery that's having a little bit of a charging problem, intermittent charging problem. The battery's intermittently going dead. When Mark and I went down there and ran it, it was working fine. It was charging just fine. I did find something like a half a volt drop across the field circuit breaker, which is so old you can't even read the lettering on it. It's worn off. There shouldn't be a half a volt drop across the circuit breaker. So I don't know if that's the problem or not, but I found enough of a problem to say that part needs to be replaced. But at the end of the day, it could come back. So were I not the owner operator, if I was dealing with someone else, I would be saying to the customer, okay, well, I found this problem. I'm not completely sure that this is it because of the intermittent nature. We'll fix this, but let's keep working with it because it may come back. So again, it could take a long, long time. I've one with this darn intercom that I've been playing with a buddy of mine. It's been going on for years. And no matter how we address it, the pattern of failure is it's got to be the intercom. Got to be the intercom. Everything else has been replaced, and the intercom has been replaced multiple times. Got to still be the intercom. There's no possible way of how it fails that it can be anything. The only common denominator is the intercom. Now I'm sort of on them like it's like, you know, I know somebody that's got a completely different model of intercom. Let's wire it in there. I'll borrow it to us. Let's wire it in there and see if the problem goes away. Because I think it's a design flaw with the intercom. And I think I've gotten convinced. Okay, so one of the things you're going to want to make sure you do is when you think you have found the problem, verify it again and again and again. When you think you fixed the problem, verify it's fixed, and then verify that everything else works. In fact, it might be a good idea before you do anything to verify what actually works and doesn't work. Because the customer may not be very forthright with you. They may come in and say, yeah, I got this little noise here. They don't tell you that the landing light and a bunch of other stuff isn't working, right? In fact, they were going to wait until after you give it back to them and say, oh yeah, well that used to work. That's a little bit of a cynical, but unfortunately I've had that happen multiple times. So particularly in electrical diagnostics, because people really don't know what they're doing, they don't understand it, it's not uncommon for people to sort of be a little sneaky about it. So when you first start working, before you do anything else, just do a full circuit, test everything, make sure it's working. And if stuff isn't working, you don't berate them, you don't hook them up, you know, call them up and say, hey, you didn't tell me this. But you can call them up and say, hey, you know, before we got into this, we started checking a bunch of stuff. We found a couple of other things weren't working. Do you want us to look into those? Okay, well, you've made note on the invoice, right? Made clear, compelling record that this isn't working before you've done anything, right? And of course, if they say yes, you know, the estimate goes cha-ching, cha-ching, cha-ching up, you know, right? So verification is really, really important, with the caveat that if the potential problem is a short, don't burn up the airplane. Okay, that's not a way to keep a long-term customer. Bothers the customer greatly. In almost every instance, sort of contained systems of electrical systems, like on an airplane or in a building, etc. If you look at that diagram across there, what it really is a whole bunch of parallel paths of series circuits. So if you can isolate everything, all the problems down to one or two circuits, that's to your best interest. So in this case, your friend is the circuit breaker, right? Go through and pop all the circuit breakers that don't have anything to do with it. Then go back and verify that the problem's still there, and something really isn't weird, like a ground path or something. Okay, so good schematics are going to help you do that. If you have some familiarity with the system and prior experience that problems have occurred, you might use that as a criteria for prioritizing things. Otherwise, prioritize based upon what's easiest to check. Okay. Engine doesn't start that well. What's easiest to check? Well, you might think checking battery voltage, but who knows? that battery may be way the heck down there in the tail cone, right? So it might be a little bit easier to kind of get the upper cowl off, turn the master on, and check the voltage somewhere else, right? But whatever is kind of easiest to get to. Otherwise, likelihood of failure. Okay, battery is probably likely to fail, right? Maybe it's easier to just go pull out the logbooks and say, how old is the battery? Oh dear, it's 9 years old. Okay, that was a pretty easy check, right? Logbook's right there, 9 years old, pretty easy to check. Now I'm going to dive into the battery because the likelihood of the battery being the problem went up dramatically, right? Okay. Particularly if they did it themselves or they had their cousin Ernie do it. They don't like to admit that somebody else has done something. Big red flag. Anytime there's any evidence that work was done recently, and they didn't tell you about it, okay, that's, you can stop, go look there and see, could the work that was done, either attempting to repair this before or something entirely different, could that have led to something being disconnected, crimped, pinched, somehow or another altered? Okay. Again, it can be kind of obscure, but sometimes they are related. It can be a little bit difficult to get known good data. However, as I presented some of the information about basic systems, you know, we know batteries put out kind of pretty common voltages, right? We know sensors of the resistive type have pretty much a narrow range of resistances that we'd expect to see. We know most digital computing systems nowadays, when they do feed power to a sensor and bring it back in, they're going to operate on a 5-volt bus. Okay, regardless of whether their input voltage is 12 volts or 28 volts. All of their sensors, their temperature sensors, map sensors, whatever else they're doing, the fuel, fuel gauge, fuel flow, they're all going to operate on a 5-volt bus. They may even have you just set up an independent 5-volt bus. So there's some commonality throughout all of this that help us with some sort of general practice. Having said that, a lot of times you might have to go to a troubleshooting chart or one of those little flow charts, other maintenance manuals to get decent data, right? What is the resistance here? What is the voltage there? Now, my experience has been if it's a system I'm fairly new to, it really helps to go make a Xerox copy, a photocopy of the schematic, and then sort of do some research and say, okay, they say measure from here to here, and they say 12 volts from, or 29 volts at this point between here and ground. Like a little note there, and use some symbol like GD for good data, or good, just a G. That's what it's supposed to be. Then when you go measure that, write down actual. Okay, right next to it. All right. Anything you can do to get that kind of what you should expect to see when it's good, and it's even better what you can expect to see when it's bad. It's below a threshold or above a threshold. The data can be all kinds of numerical values. As well, it can be either voltages, resistances, maybe even current readings. I find I actually don't need to measure current that often. Every once in a while it's helpful, but for the most part, you don't really need, in terms of isolating where the problem is, you typically don't need to read no current too much. The oscilloscope patterns, I've used them a lot, and somewhere, I don't remember where I've done, I used to have a really big library on scope patterns, but the bottom line is most of the time, if you're resorting to oscilloscope, numerical data being represented on a oscilloscope pattern, more often what's broken is the wire is broken, so you're getting digital data or you're not. You don't really care what the data is. If you really do, if to the point that you really care what the data is, you're not doing sort of engineering stuff. You're gonna still change that unit, okay? The unit itself is bad. More often what we're gonna do is we're gonna say, here's the component that controls everything. Does it have all the appropriate power, ground, and input data? Is it putting out appropriate data? And what it's putting out to, is that functional? Does the motor actually still work? Does the injector still work? Does the whatever still work? If all of those are true, then it's the unit in the middle. Rarely is it the unit that's in the middle. Okay, so you got to have good schematics, fairly good data about what are appropriate and inappropriate values. The other thing a schematic will help you with is, where do you measure? Where do you sample from? Not just cut the wire. Well, so then you sort of have to ask yourself the question, do I measure it in the connected state or disconnected state? Doing voltage drop checks, you usually, one of the reasons I like them so much is because you're measuring things in the connected state in a dynamic environment. That tells you what, you're measuring the circuit while the circuit's working. Very, very useful. A connector is still a pretty good place to go into. You can either back probe the connector, particularly if it's not an environmentally sound one, where you can just slide a small push pin in there. You could use the connector to isolate a section of a circuit, or a circuit breaker, pop, 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 pop all the circuit breakers till you just got the one part you're using. One of the things you may find yourself needing to do, though, is if you're going to have the circuit on for a little while, you're going to have the master switch on for a while, pop all the circuit breakers and hook up a battery charger. Just a small trickle charger, something that, because you're going to need to go at this for a couple of hours, you don't want to deplete the battery, right? So nothing wrong with doing that. The schematics can also help just physically locate where stuff is, where the connector is, where the ground is, where ground interconnections connect several different circuits together. Okay, you go look at that wiring diagram over there, and it shows you power distribution, right? It doesn't necessarily tell you that all the grounds come back. Or one of the things that circuit doesn't, in fact, none of the schematics here, because I've got them all, I've looked at them, one of the things those schematics don't tell you is that the way they wired this building is all the benches have individual circuits going out, but one common neutral going all the way back. And that common neutral actually isn't enough to handle the load. I'm waiting for the day that you guys get out there and you plug in something big in every one of the bench receptacles and turn them all on at the same time. It's going to be fun. It's going to be fun. I got it all well documented. And then I'm going to go to the board and say, hey, board, look what you did. You approved this building. You shouldn't have done that. But you guys are incompetent. Yeah, I see. I mean, if you know what you're doing, you can see it with your plain eyes, but you go back and look at the schematic. The schematic doesn't show that. And none of the schematics actually show that. But they may show parts. Another one may show, gee, look, that bolt right there has 9 different connectors going to it. And they're all ground connectors. Well, we already know that's against the rule, isn't it? What's the FAA say? No more than 4 terminals on lug? Okay. All right. So again, these documents can help you, but they are kind of confusing. Look at that one that's there. That's out of an A320. Okay, and it's only one little small snapshot of one little bitty area. Kind of confusing. The other thing they often do is they show you a magic box. Magic box. They don't show you anything that's going on inside that little magic bugger. It's just the magic in there. Well, it kind of sometimes helps to know what's going on in there.
Do they give you conditions for in and out?
They may or may not. Yeah, I know. Or they do, but it's in some other obscure manual somewhere, right? Okay, if you actually determine that a part is bad, there's a really good chance there's something else that caused it to be bad. Stuff fails for a variety of reasons. Heat, vibration, just old age, okay, batteries, old age, right? A little bit of water getting where it's not supposed to be. Dirt and grease getting where it's not supposed to be. If you can determine that any one of these things were a factor in why it failed, that's a good thing to do. What you don't want to do is find yourself in the situation of, I know this part's bad, I don't know exactly why it failed, I'm putting a new part in and it may fail too. Okay? You can throw parts at it till the symptoms go away, but it might behoove you to invest a little bit of time in figuring out what and why something failed. The circuit breaker was one that was intermittent. It was actually intermittent for quite a while. Drove the fuel pump, and it was intermittent for quite a while, and then it eventually failed. I was actually on a very long trip, so I couldn't actually do much diagnosis with it. When it finally failed, I actually was out there in the middle of nowhere, so I was able to move the circuit over to another circuit breaker that wasn't being used for anything. But I took the time to cut it open and figure out what actually went wrong. Because I wanted to know what was wrong and be able to establish that something actually was wrong. Running, auto shut it. Writer. All the way up. So the leads come in to these pigtails, and then the pigtails attach. Well, as you can see, the lead came in to here, attached the pigtail to the part that moves, and the pigtail separated from there. Now, just as this thing was going intermittent, if I'd had the equipment with me and been able to get there and turn the circuit on, fuel pump running, I probably would have measured a little bit of a voltage drop across here. Okay, a quarter of a volt, a half a volt, or something that shouldn't have been there, right? As these wires eventually broke. Now, what failed is, I don't know how many times that circuit breaker has been turned off and on, 1,000 times. Way less than it was certified for. Most of these little contact switches are certified for, 250,000 operations, 2 million operations, something like that. What probably caused this to fail was sitting in an instrument panel vibrating, micro vibrations coming off the engine. And that little bit of copper sat there going, eh. And this end was spot welded, spot fused to that tab there. So that meant the copper was just swedged onto there. And this was a nice clean break. There was a stress riser here. So with the weight of the copper bouncing and vibrating over 2,300 hours of operation, it finally managed to wiggle its way to broken. Now that's in a row of a whole bunch of other circuit breakers. Should I replace them all? I'm Scottish, hell no. Not a chance. I'm going to make them break one by one. again, that's actually not something I, as a mechanic, choice I should make, but it is certainly not a bad option to go to the customer and say, hey, look, this broke because of vibration. Now, it may have been there was a flaw. When this thing got made, it was already partly damaged. Just a screw up. It didn't get made right. So maybe there's nothing wrong with any of the other ones. However, make the customer aware. Make them make the choice, not you. The other side of this is I have now verified, clearly verified, that the problem wasn't because this thing got overloaded. Stuff wasn't melted. It was clear it broke just because of vibration and wear and tear. Now, I don't know that I'd charge the customer, who in this case was myself, for that. But I'm one that always tries to go back and establish, why did a part fail? What failed and why did it fail? Okay, now let it go. Okay, we need the PC back. PC back. It won't go back to the PC. Bad computer. Oh, there it is. Okay, whatever. So, if you can establish why something failed, please do. I assure you that this right here, this charred, burnt, blown apart driver transistor, that failed because of the load that it's attached to. I don't need to do any other diagnosis. The amount of current being conducted through this thing, enough to literally blow it out of the transistor, as well as blow it right off of the circuit board. Okay, somehow or another, the output of that transistor current went way, way up. It was either dead shorted or the load itself had an internal short, and it failed it. There's no way in the world I would take that circuit board, replace it, or that transistor and replace it, put it back into service without making sure that the output side of that thing hadn't also been thoroughly checked and tested. Okay? Now, could I actually find that transistor? Yeah, I actually might be able to order it. But in most cases, what I would do is replace the entire component. Okay? After making sure I found out what caused that thing to fail. Very, very, very expensive. You're in the back of a 787 and playing with $1 million modules, and your career is going to get a pretty good dent if you start frying $1 million modules. You know, it's actually, I would love to say this is a fairly rare event, but it's really, really common to have multiple problems going on. I'm surprised at how often it happens. And they may not even be totally related, but I just gotta say it, many, many times I've found one thing wrong and there are several other things going on as well. Sometimes they're minor, sometimes they're related, sometimes they're not. So it's in my best interest as a technician trying to keep the customer happy to be thorough, verify everything, assume there are multiple problems, and this is particularly true if there's any evidence that somebody else has been looking at this. Cousin Ernie, good old Cousin Ernie's been looking at it. There's sort of a funny inclination on the part of humans. If that sort of goes, I've had this problem, I'm a little frustrated about it, and I know it's painful, it's gonna cost me, it's gonna be more painful, and it's gonna cost me. So if I don't say anything, maybe it won't cost me that much. It's a form of denial, but it's very real. It happens. Sometimes there's ego involved as well. And certainly if the pilot's telling you what they think is, or the owner operator is telling you what they think is wrong with it, okay, big red flag, they are not the expert. Leave room for their ego to say, oh, well, that's good, thanks, I'll make a note, thank you for that. Okay, oh man, that's good to know, you know, just kind of go with it, but big grain of salt. If they say, oh yeah, it's the white eagle thunder bearing, or the, you know, the Fergified monkey's egg, whatever it is, something, you know, they start coming up with stuff. It needs a tune-up. Okay, you know, yeah, okay, great, you know, but on the other hand, if they're saying, God, you know, I turn it on and I do this and I get that and the light, there's a little bright flash, and then everything stops working. Okay, that's useful. There was a little bright flash. They did this, that, and in this situation, it occurred. That's very, very useful. Okay. Absolute symptomology that you should be able to go back and re-verify. Certainly, the upside of multiple symptoms is that then allows you to do a little bit of analytical thinking and say, okay, in the schematic, I've got the wiper system and I've got the stall warning system. Where do they overlap? Okay, getting problems with both, where do they overlap? Is there a place that they overlap? Do they both have the same power source? Do they both have the same ground? They may not be related at all, but there's a reasonable likelihood that if they're both behaving badly, there's some common denominator that's causing both systems to fail. Okay? And again, anytime there's new parts that they're not fessing up about, be worried. I will say I've had this happen. I've actually had it happen more than once. The first time, unfortunately, it was a major trunk artery of wiring harness, you know, forward of the firewall and after the firewall. And I'm like, there's, you know, 70 or 80 wires going in. And the one wire that I think is the problem, I got voltage going in and out the other end I got, well, I can't even find the darn wire. It's like not there. Purple green going in and not there. You know, the schematic says it should be there. But finally it's like, all right, go through to the other end and chart every single wire that comes out. I got this, that, and list them all out. There's no purple green, but I have a new wire. Okay, I got a red white that doesn't go in the other end. So, and lo and behold, this was the same wire. They decided, well, gee, we're not going to stop. We ran out of red green wire or whatever it was, purple green wire. So we're going to stop building these cars. No, they're just going to grab the next spool of line and go on, make a note, and hope somebody catches it. It'll happen. It's rare. It's happened to me twice. The other thing I've had happen, and actually one of them was on my airplane, was a wire break in the middle of the insulation. The insulation was fine. In fact, very carefully cutting it open, you could see that the strands of wire got stretched and broke in the wire making machine. And the insulation just filled in, looked just fine. And over time, in one of them, it was actually an audio line coming out of, and I hadn't even built up the harness. Somebody else had built up the harness. But so it's rare, but that kind of stuff does happen. So don't assume the schematic or the manufacturer's information is wrong. In 99.999% of the time, if it isn't making sense to you, it's because you're broken. The schematic is fine. You haven't got it down yet. Haven't figured it out yet. Don't be afraid for asking for help either. It's okay to ask for help in this case. A lot of this stuff can be kind of weird, and in particular, the symptoms are pretty weird. A couple of heads can help. These things will do pretty bizarre stuff. I have to tell you the number of times that I've been, back when I was a shop foreman, and you know, people would say, hey, I need help, and I get over there and I'm like, okay, where's your schematic? Okay, you owe me lunch. All right, and if it happens again, you're buying me dinner down at Island Prime. Okay, the big prime rib, yeah, baby. They got a baked potato, twice baked potato. I kid you not, it's this big around. They must genetically like, go to Mars and get these things. Man, how is good food. Lobster, cheddar, baked potato, twice baked potato. You're gonna buy me that if I show up and there's no schematic sitting there. Okay, because you're taking away from my labor, my earning money to help you out. I'm happy to do it. But so I get over there, you got the schematic, and you say, man, I measured this and I measured that, and I'm looking for voltage there. Well, but that's ground and that's ground. If you've got voltage there, you definitely got a problem. But in truth, switch it to ohms. There you go. Okay. Now, right? Okay. So make sure that you have some sense of what you should be getting at any given point. And again, it can be very confusing. Those of you guys that worked on the twin turbine troubleshooting board, that's a complex system. It's pretty complex. I highly encourage you, if you want a challenge, pick that one. But it can be fairly easy to get lost, particularly when the schematics are spread out over 10 pages or 12 pages. And they've done a terrible job of describing what happens in the little magic boxes. They've done such a terrible job that I actually went back through, figured out how the magic boxes work, and tried to add in those schematics for you guys, because it really is badly done. Okay, parallel paths and your reading resistance, all bets are off. Okay, it does not matter what you're trying to do, the data you get will be no good. It'll be corrupt, bad, no bueno, if there's any parallel paths. And I see this all the time. People measuring between A and B, and there's 9 parallel paths in that measurement. Fortunately, the upside of a digital voltometer is they have this little thing that says OL, out of limits. Danger, Will Robinson. Danger, Will Robinson. Now I'm dating myself, right? It means you hooked it up bad. Here's the thing that I don't get, and this is kind of bizarre. If you go over to that Simpson meter, which is kind of an antiquated thing, they're very useful for some things. They've got, if you hook it up wrong, it's got this really cool little circuit breaker in there. Pops out. They should put that in every one of these meters. Now you don't need it for ohms or volts because the digital meter is so good. They're 10 million ohms. Okay, really, really high impedance. You're not going to damage it unless you hook it up to 1,000 volts or something. You're not going to do damage to it. However, the little ampere thing over there, what's going to happen is you're going to rotate it over to ohms or volts. There you go, volts, and you're going to hook it up, forgetting that the last thing you measure was amps, and you've got the lead stuck over. Okay, and you just dead short, and it blows the fuse, which of course you don't have one. So you go out and buy one, and then the next time you do it, you buy 5 because you know you're going to do it again, right? They really should design these guys with a small little circuit breaker. And in fact, they could put an automatic auto resetting circuit breaker in there. They're cheap little units. It doesn't cost them anything to do that. So do make sure that stuff is correctly hooked up. Don't use your ohm or amp meter for voltage tests. And I know you guys struggle with this because I don't do it as much in this class, but in the power plant electrical class, some of the written projects are, how do you do this? How do you check for a short? How do you check for an open? And as you guys do these, what you show me is you're still, even though you've passed DC electrical, you're having a hard time getting how to correctly do this. I want you to be able to understand this. And the only way to do it is to, go out and test a bunch of circuits, and then pretty soon you start figuring out, okay. Please try to avoid not punching holes in wires. They make these really cool tools that are doing that, and sometimes you don't have a choice, particularly if they use pretty sophisticated. These are actual General Motor connectors, which actually are being used in some places in aviation. It's got a nice rubber gasket there. It's also got a rubber gasket inside, and so if you try poking a hole in there, you're going to environmentally compromise that connector. I do have some push pins, some thin, long push pins that I've altered a little bit they're really sharp, and what I did is I rounded it off a little bit, so it doesn't have a tendency to puncture, but it'll slide in behind the rubber and go into the point that it's actually, butted up against the metal, and then I can have that connector connected, operating, and a place to sample from, okay? It might be a real bear to get to. One of the things I will tell you about aviation connectors is they're usually designed well enough to where they actually easily come apart. Automotive connectors, these plastic kind, I don't know about you, but that little clip, you go to loosen the clip and you go, and it doesn't come apart. It just does not want to come apart. By the time you get it to come apart, you've ripped all the wires out of it, right? Okay? And the little tab thing snapped off a while ago. Okay, it is not coming apart. And of course, you're down in a little hole trying to get to it. So there is a tendency to want to get some kind of cool fancy tool and puncture a wire. Again, if you have to do it, come back with some electrician silicone and seal it back up. Just put a little dab over there and rub it in and seal it back up.
Is that something you'd have to report then? Is that something you'd have to report or not? You.
Again, it kind of depends on what who you're operating under, where you're working. Under Boeing, yeah, they might be that severe, but my general sense is a better way of doing that. If you really need to do that kind of thing, what they have is they'll have breakout connector boards where they actually have the male and female connector. You disconnect, connect to this unit, and it's got a bunch of sample places to connect into.
Okay.
Okay, that's a better way of doing it. If you really need to do that kind of stuff, I don't recommend doing this, and I do everything in my power to prevent putting holes in wiring insulation. The only reason I say that is because many times I've had to come back 4 or 5 years later, and that wire is filled full of green stuff because there's a hole in it, and water managed to migrate up into the wire. So truly, anytime you can verify, particularly if you're getting any intermittent, jiggle stuff, wiggle stuff, get it warmed up, get it really cold. Manufacturers like Garmin or King or whoever, they actually have vibration tables and ovens and chillers that they'll put their components into to try and replicate or create extreme harsh conditions to get the problem to occur, particularly if they're intermittent. Again, the big advantage of a voltage drop is oftentimes I've been able to find, or not often, but I have occasionally been able to find an intermittent that wouldn't display the behavior for me, but I was still able to read a voltage drop where there shouldn't be one, fix that part of the circuit, and the symptoms went away. Okay? And again, once you think you fixed everything, verify all related circuits. Make sure something new didn't sneak in there. The number of times you pull a connector apart and put it back together, at some point you might get a pin pushing back or bending or doing something. This is something, I don't know, I see a lot of guys have a hard time with. Connectors should go together and they should be a little stiff. Okay, they should be a little difficult to go in because each one of those pins are pushing into a positive contact, but not so much that you damage it. And I gotta say, I've seen a lot of damaged connectors because people just sort of shove it in there, grind it shut and grind it closed and damages stuff. Okay, be sensitive to that. So yeah, verify all the other circuits. It's very, very possible that you can add problems to. That's why I say multiple things occur. Because you've taken stuff apart and put it back together, you introduce other issues. The bottom line is if you're very thorough, everything works like it should, you've done a lot then to ensure that the customer is happy. They feel like they got the value for what they're paying, because they're going to pay you a lot of money, right? You pay somebody a whole lot of money, you get in and the interior light no longer works. How are you going to feel about what you just paid? Right? It's going to be annoying. You're going to feel like, well, man, did this guy really do a good job? Okay, well, that's kind of, we wanna make sure that doesn't happen to our customers. And you really wanna make sure that when they turn things on, smoke doesn't come out. Okay, that really, really doesn't do well. They're not coming back. No matter what happens, how you remediate that, they're done with you. They're not coming back. Another thing, and I'll stop here and then we can go take our break. Another thing that it's really important to be sure about is, I've already said, if there's any evidence of other attempts to fix the problem, you get in there and new parts, it's clear, all the dust is off. These connectors and stuff have been pulled apart and put back together, and nobody's told you about this. You're really gonna, or things have been modified. You're really gonna have to back up and say, whoa, wait a minute, time to call the customer back. Say, look, there's some stuff that's been modified here. This is not the way it's supposed to be. So at the end of the day, I cannot sign this airplane off and the work I've done as airworthy until it's been brought back to airworthy standards, meaning it's the way the manufacturer wanted it to be. Now, where I used to see this all the time was in carburetors. Back in the day with carburetors, with all these vacuum hoses, they put all these vacuum controls on there to try and get the vehicle to be able to meet emission standards. That's why they got rid of carburetors and went to fuel injection. It simplifies everything. Well, people get in there, they don't understand how that goes, so they just take them all out and put a bunch of plugs on, or hook them all up whichever way. It was so bad, the state of California said, you cannot sell a car unless you put a big map right there on the hood somewhere that shows how all the vacuum hoses are supposed to be hooked up. Didn't do a darn thing. People just couldn't figure it out. Didn't do a darn thing to help. I made so much money pulling all that stuff off, buying a bunch of new vacuum hose, hooking it up correctly, and bringing it back to OEM. However, before I did that, I called the customer up and say, look, this isn't right. And I'm gonna have to charge you to bring it back to the baseline, the way the manufacturer originally wanted it. And the auto industry, that's what I would say. In the air industry, you can't even go there unless it's back. Because at the end of the day, that plane isn't airworthy, is it? It's got to be brought back to airworthy standards, then begin the diagnosis problem. Okay? And it's fairly common for people who don't really know what they're doing to throw parts, rewire, do stuff, silly stuff, in attempts to make the symptoms go away. I've seen some really expensive ones. Little temperature sensor in the air conditioning. A little temperature sensor that says if we're not getting cold air, we're going to shut down the compressor. Because if we're not getting cold air out on the evaporator side, that means there's nothing that's causing the Freon to turn back into a gaseous state. What's going to happen when liquid Freon hits that compressor and doesn't compress? Because it's liquid. It's going to shatter the compressor. And where's all the metal that's shattered going to go? Back throughout the entire system. Yeah, some idiot decided, well, that sensor's got a little bit of problem, we'll just bypass it. Okay. That cost the customer $4,000 in a car that almost wasn't worth $4,000 for a 39-cent sensor. Okay, yeah. Of course, I got to it and everything shattered. Like, what could possibly have caused this? I've never seen one grenading quite this bad. We're not doing anything until I check everything. Gonna have to pull the instrument panel and everything out anyways. Sure enough, there's some idiot just cut the sensor out and taped a little tape, hooked it, bypassed it, right? Yeah, okay. All right, so we'll end on this slide. The good news is there's really only 3 things that could go wrong. Right? We could have additional resistance all the way up to infinite in a circuit. That's one of the options. We could have a reduction in resistance. Somehow, some part of the circuit is being bypassed, partially or entirely. Okay, this usually is very spectacular, provides lots of evidence in a bunch of different places occasionally. The other one, sneaky. And this is usually the most common failure. This one and this one here. The battery's dead. The generator isn't genning. Okay? This is fairly common. This is really common. This is actually remarkably rare. It doesn't happen that often. I guess it's a testament to pretty good securing, pretty good lacing, good insulation, good conduiting, etc. It's a testament to pretty good design that we don't see too many shorts. Every once in a while, you see evidence of one on the side of the freeway. There's a big charge spot, right? Most car fires start from electrical, not from anything else. So you do occasionally see it, but most of the time it's an open or a failed electromotive source. All of these easily isolatable with a decent schematic and a voltmeter. Doing voltage drop checks or initial voltage checking. A short is a little bit more problematic, but you can still use the exact same tool. You just put a false load in there. Okay, pop the circuit breaker or pull a fuse out and put a light bulb in there. Something that gives you a false load so that you will limit the current. Okay, then start doing the same exact checks. Right? Very common to see this. Okay, the battery is getting a little old, the generator is working a little harder, the generator is getting old, it finally pops, blows a rectifier, something else goes wrong, battery gets really deeply discharged, right? You charge it back up, it's pretty weak at this point, check everything out, yeah, the battery's sort of hanging in there, maybe, kind of, sort of, maybe. Generator's toast, you put a new generator in, 2 weeks later, the battery gives it up, right? Well, after you've seen that a few times, you're going to say to the customer, hey, here's a likely scenario based upon everything being kind of old. While we're at it, let's do these other things. But if you don't want to, that's okay. Make a note. That way when they come back 2 weeks later saying, well, you didn't fix this right. Well, yeah, actually I made a note saying here that this is exactly, that this was potentially or likely to occur. Okay. Let's see, how about we come back at, say, 10 till?